All right, let's get into it. Today, we're going to break down one of the most common statistical tools out there, the one-sample t-test. And we're not just going to talk theory. Nope. We're going to crack open a simple case file to see exactly how this thing works in the real world. So let's dive right in.
Okay, so picture this. You've just wrapped up a study, you've got your data from a small group of people, you calculate their average, and, it looks a little different from the national average. So what's the deal? Is that difference you're seeing a real thing, something meaningful, or is it just, random luck? How can you possibly know for sure?
Well, that's exactly where our tool for today comes into play. The one-sample t-test is built for this very problem. It's a neat little test that takes the average from your small group and puts it head-to-head with a known average from the entire population. And then, and this is the cool part, it tells you if the difference is statistically significant. All that really means is it tells you if the difference is the real deal or if it's just a random fluke.
So, to really see how this works, let's open up our case file. We're looking at a study of some men in the UK. And our mission, basically, is to figure out if this small group is a good representation of the average guy in the UK.
Okay, so here's what we have to work with. The official numbers from back in 2017 tell us that the average adult man in the UK was about 178 centimeters tall and weighed around 83.6 kilograms. Now, our sample is just 23 guys. So the big question marks here are what we're trying to figure out is our little group's average height and weight any different from the national numbers in a way that actually matters?
All right, before we start digging into the clues, every good investigation has rules, right? You got to follow the rules. In stats, we call these assumptions. And sticking to them is super important because it's what makes sure our final verdict is actually trustworthy.
So here are the rules for a fair t-test. Pretty simple stuff, really. First, your data needs to be on a continuous scale, like height or weight where you can have decimals. Second, all your data points have to be independent. Basically, one guy's height doesn't influence another guy's height. Makes sense. And last, the data should look kind of like a bell curve, what we call normally distributed, with no really extreme, wacky values or outliers messing everything up. And for our case file today, we're all good. All these conditions are met.
Okay, rules are established. Now for the fun part, analyzing the clues. We're going to look at two things separately here. First, the height of our guys, and second, their weight. Let's see what the evidence tells us. All right, first up, let's look at clue number 1, height. The raw numbers show our group had an average height of about 177.6 centimeters. Now, you and I can see that's super close to the national average of 178 centimeters. I mean, it's barely different at all. But the question is it close enough for a statistician? Is that difference just noise? The real answer is hiding in these results. Okay, I want you to zero in on the most important number you'll see here, the p-value. For height, our p-value is 0.706. That one little number, that is the key to everything for this clue. So what on earth does that actually mean?
So a p-value that high, and trust me, 0.706 is high, way above the usual cutoff of 0.05. It's basically shouting at us that the tiny difference we saw, it's not significant. It's almost certainly just random chance. So the verdict for clue number 1, our group's height is, for all intents and purposes, the same as the national average. Case closed on that one.
Okay, but let's not jump to conclusions. Let's move on to our second clue, body mass, or weight. Now, check this out. Our sample's average weight was only 72.9 kilograms. The national average is 83.6 kilograms. Now that sounds like a pretty big difference, doesn't it? But again, let's see if the t-test agrees. Is this difference the real deal? Whoa. Okay, now this is a totally different story. Just look at that p-value. It says it's less than 0.0001. That number is tiny. It's practically zero. This, my friends, is what we call the smoking gun in our investigation. A p-value that small is telling us that there's less than a 0.1% chance that this huge difference in weight is just a random fluke. So the verdict here is crystal clear. The difference in weight between our sample and the rest of the population is absolutely 100% significant. This is not just random noise. This is a real, measurable difference. So there we have it. We've looked at both clues. For height, nothing to see here, pretty much average. But for weight, we found something really, really significant. It's time to wrap this case up and deliver the final verdict. And here's how a researcher would actually write this up in a report. You can see how clear and to the point it is. It says, hey,
The one sample t-test showed no big deal with height. However, the participants were significantly lighter than the average UK guy. It's the perfect, concise summary of our whole investigation. So you see, the one sample t-test is a really powerful tool. It lets us look at some numbers and get a real evidence-based answer about whether a difference is real or just random noise. It helps us see the signal through the static. So that leaves me with one final question for you. Now that you've got this tool in your back pocket, what kind of question could you investigate? Could you test if the pizza deliveries in your town are actually faster than the national chain's average? Or if the students at your school get more sleep than the recommended amount? The possibilities are literally endless. What will you discover?